Hey kids, this is Mr. Cozy and this is video 21. We are talking about rate time problems. This is a particular type of a word problem that has a lot of variations. There's a lot of ways you can write it. I'm just going to show you a few types of these problems. These are examples 5, 6, and 7, starting on page 9 in the book. Here's the equation that we are concerned about. If we have some kind of a rate, and I multiply that rate with a time, what I get is some amount of something. Now, a very quick and easy example of this is if I'm traveling at 70 miles per hour. That's my rate. And I travel for 2 hours. I will have traveled 140 miles. So I have rate times time equals some amount. Okay? So keeping this in mind, let's look at a few variations of this problem. I have two ships traveling between San Francisco and Honolulu, which are 2,100 nautical miles apart. The ship leaving San Francisco is traveling at 15 knots. The ship leaving Honolulu is traveling at 20 knots. How long will it take the two ships to rendezvous, and how far will they be from Honolulu and San Francisco at that time? This is the question that we really have to answer. I have a distance and I have a couple of rates and I need time. So let's let t be the time until rendezvous. Okay? So the ship leaving San Francisco travels so far. The ship leaving Honolulu travels so far, and they meet in the middle. And t is the amount of time it takes for these ships to meet. Okay? So, keeping that in mind, how far did the ship from Honolulu travel? If it travels t time. Well, its rate is 20 knots, so the distance, the amount it traveled, is 20 times t. The ship leaving San Francisco traveled 15 t distance, and they met in the middle. Now, when they meet collectively together, as we can see, these two ships will have traveled 2,100 knots. And therefore, the setup for my equation is that 20t, this is the ship from Honolulu and how far it has traveled, plus 15t, this is how far the ship traveling from San Francisco has traveled. Well, this equals 2,100 knots. And with this setup, I can solve this problem. 35t equals 2,100. I divide each side with 35. I'm going to get 60 hours. It has taken 60 hours for these two ships to meet. At the time that they have met, this ship will have traveled 15 times 60, 900 nautical miles. So that's the distance from the rendezvous to San Francisco. The ship leaving Honolulu, 20 times 60, will have traveled 1,200 nautical miles. So that's the distance from the rendezvous point to Honolulu. Guys, note that the key here is that these two speeds combine. They add up. And therefore the distances these two ships have traveled also add up. This is the kind of setup you would also use if the ships started at the same location and traveled in opposite directions. You would use this same setup where it's the distance of one and the distance of the other. Add them up and you get some kind of a total distance. Okay? Alright, let's move on. An excursion boat takes 1.5 times as long to go 360 miles up a river than to return. If the boat cruises at 15 miles an hour in still water, what's the rate of the current? Alright. I want to know the rate of the current. So let's let x equal the current. Okay. Now, I know that going upstream against the current, the boat is traveling at 15 miles an hour minus the current. Okay, so this is the upstream speed. Downstream, heading with the current is helping you out, so 15 plus x. Okay? What else do we have? We have it 360 miles, so that's going to be my distance upstream and downstream. My time is a little weird. The time going upstream is 1.5 times the time going downstream. So there's another unknown here. There's some other thing that I've got to figure out. I don't want to make a variable for it. So let's just have a blank. I have blank time. That's the time going downstream. And the time going upstream is going to be 1.5 times that. Okay, I think this is where our equation is going to be. That the time going upstream is 1.5 times the time going downstream. Okay. Now, the time going upstream, that's going to be remember that rate times time equals amount. Okay, so if I want to find time, I'll have to divide the amount with the rate. Going upstream, I'm traveling 360 miles, and my speed is 15 minus x. going going downstream, I'm going to have 1.5 times the same distance divided by 15 plus x. And here's my equation. So let's highlight some pieces so that you see how they relate. This is my distance. This is my rate up and downstream, and this is my time up and downstream. And the fact that my time upstream is 1.5 times the time going downstream, that's how I set up this equation. Now to solve it, what I need to do is multiply these two fractions together. Now you may not see a second fraction here, but I do. Okay, 1.5 times 360 is 540. So I'm going to have 360 over 15 minus x equals 540 over 15 plus x. Okay, this is up a proportion, so I can cross multiply. 360 times 15 plus x equals 540 times 15 minus x. Multiplying this through, I'm going to get 360 times 15 is 5,400 plus 360x equals times 15, 8,100 minus 540x. Getting everything to one side, minus 5,400 minus 5,400 plus 540 plus 540. I'm going to have 900 equals 2,700. So dividing these, I get that the current is at 3 miles an hour. Okay? All right. So get one more. An advertising firm has an old computer that can prepare a whole mailing in 6 hours. With the help of a newer model, the job is complete in 2 hours. How long will it take the newer model to do the job alone? This is actually a rate, okay? My amount is one job. That's my amount. So the old computer operates at a rate of 1/6 of the job per hour. Okay. If my amount is one job, then the rate of the old computer is 1/6. The new computer has a rate of 1 over, I don't know. Okay, that's my question. Let x be the time for the newer model. Okay? Now, these two computers are working together for 2 hours. And if I put them together, I get one job. There's my setup. Okay? In each case, I have a rate times a time. So working this out, I'm going to get it's my highlighter. 2/6 plus 2 over x equals 1. This is going to simplify to be 1/3. So I'm going to subtract 1/3 from each side. And so I'm going to have 2 over x equals 2/3. 1 minus 1/3 is 2/3. It should be obvious from here. If not, you can solve it out that x equals 3. So it will take my new computer 3 hours to do the mailing. Okay, I'm way over time. I'm sorry. We will cut things off here. Guys, these are just a few variations of rate time models. We'll look at others later. Have a great day. Bye-bye.